Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. While working on a regulator circuit for a controlled rectifier, I found this component bad. It was a short circuit. It is DB3. The part number mentioned on the body, it is DB3. It is looking in a Zener packing or glass packing. When we say diode is in this shape. When we say it is a Zener, Z shape is there. But sometime we see a component back-to-back diode, two diodes here. So it is combination of two diodes, Zener diode. Sometime its symbol is like this. Two diodes. This one or this one, the same. It is a trigger diode. It is used to trigger any triac or any SCR at a specific voltage level. We cannot test it using multimeter. I will show you the best test procedure. Set multimeter to continuity or diode mode. Now it is giving continuity. While we have another SMD DB3, so it will open in diode mode, in continuity mode, and in resistance mode. It is open. It is voltage activated device. Let's check it. Now I have the new one which I purchased to replace in that board. Even it is in any color, but it is the same. It have marking DB3. DB3, that means it is 30 volt. The minimum voltage level, operating voltage 28 volt to 32 volt. It is bidirectional diode for AC circuits. It is used in AC circuits. The Zener is used in DC circuits, but this Zener diode is for AC circuits. When we apply 220 volt, there is one 10 kilo ohm resistance and 500 kilo ohm potentiometer to adjust its trigger level. Then we have series resistor for adjusting the current, and then there is triac. So it will control the output voltage of this triac. How much voltage are available here? We will control the output voltage coming out from this point that are here by adjusting the potentiometer here. So when we apply voltage, let's apply how we can test it. I will use a 310 ohm resistance. (320 ohm, 330 ohm, 220 ohm, any one resistor you can use. It is 311 ohms. There are other methods. You have to use the live voltage, but I don't recommend to test using live voltage because that is also some dangerous procedure. Now I will connect 1 voltmeter across this resistor, ground and positive. The second meter across this deck, and then I will connect voltage adjustable power supply, ground here and positive here. Now this multimeter will show the voltage across this resistor. This multimeter will show the voltage across this dike. Now I will use the third multimeter. It will show the total voltage. You can use only one multimeter but it is to demonstrate DC voltage. Now here we have the total voltage from this point. This is our power supply terminal, so let's check it. Now total 53 millivolt. It is showing 53. I am increasing voltage 1.5 volt. We can see the dioc is dropping all the voltage across its junction. 4.3 volt, 4.3 volt here. There are no voltage across this resistor because this time it is working as a open circuit, and it will remain open until the voltage level will cross its threshold, that are the maximum 32 volt. We can see 11 volt, 15 volt. Still there are no voltage here. All the voltage are being dropped here. There might be some leakage current. It is 0.4 millivolt, that is in microvolt. 27 volt. All the voltage are dropped across this one. 28. Now we will see at which voltage level it will switch. When it will switch, at that time it will start conduction and it will allow to pass the current through this resistor, because this is our supply terminal, negative to positive. I am increasing the voltage 29.6. Still it is, yes, at 29.8 volt we can see it allowed the current. It is dB3. The nominal voltage are 30 volt, the maximum 32 volt. Now we can see it is allowing 8 volt because this time it started to conduct. Now if we will increase the voltage, 21 volt here, 10 volt here. Now I am going to drop the voltage. It will turn off when the forward current will drop less than 10 milliampere. That will depend on the resistor, series resistor here. Now you can see at 26 volt it is working. At 24 volt, 25 volt, it stopped the conduction. If this resistor is 20 ohm, at that time it will reach up to minimum level, that is 5 volt. That is its symmetry voltage. Again increasing the voltage, 29.8, yes, we can say 30 volt. At 30 volt it allows the current to pass, and when the voltage will drop again it will disconnect. Now the voltage dropped, 25 volt, it stopped the conduction. If we apply here some AC signal, AC source between these 2 points, because AC signal is always changing its value, at 0 volt it will stay off. When the voltage level will reach at 30 volt, at that time it will conduct, and it will remain conducted in this period until the voltage will drop across its junction less than 25 volt when we are using 310 ohm resistance. So it will conduct in this portion. So it is bidirectional. Now the second question here, because it is used in AC circuits, so we can say it have to conduct in the reverse polarity. Now I will change the polarity. I will change the polarity from the DC power supply. We will see here on the multimeter. We can say when the negative peak will start to increase, when the negative peak will reach at 30 volt, at that time it will conduct again and it will remain on until the 20 volt. Let's check it. This time I am applying negative voltage because this time the polarity is reversed. Minus 1.5 volt. The same negative voltage because this terminal is now negative. We are decreasing the voltage because this time we are in negative side. This time it negative side and still it is not conducting. It will conduct when the voltage level will reach at its junction voltage, that are the breakdown voltage, we can say 30 volt. It may be from 28 volt to 32 volt. Still 28.5 volt negative because the polarity here now reversed. At 30 volt, yes, at 30.8 volt, in one side it was conducting at 29.8 volt, and the second direction, the second diode, the second junction, that is switching at 30.85 volt. So it can switch from 28 to 32 volt. That is its typical range. Now it allows the current to flow through this resistor as it is shown in the circuit. Now I am decreasing the voltage. It will stop conduction at the same specific 25 volt. Now I will reverse the polarity again. 25 volt positive, so it will remain off. It will not allow to pass the current through this resistor until the voltage will exceed from its junction voltage, that are 30 volt. Yes, at 30 volt it started conduction. So it is used in CFL lights, in voltage regulator circuits, in generators, in control rectifier circuits. So this is the function of this dike. So we cannot test it using multimeter because it is a voltage dependent rectifier. 220 volt will applied to this 10 kilo ohm resistor and a series potentiometer 500 kilo ohms. Then 0.1 microfarad capacitor, that is ceramic capacitor, and here it is a bidirectional diode. If it is dB3, that means it is from 28 volt to 32 volt. If it is dB4, so that will 40 volt. Its value will from 35 volt to 45 volt. So in this way you can test it. You can use some AC source, but that source must be more than its rated value. For example, it is dB3, so it is 30 volt. So you can use any 35 volt, 40 volt AC. So its repetitive peak current, that is 2 ampere, and its power dissipation, that is 150 milliwatt. As we used in our experiment 310 ohm resistance, so it was disconnecting at 25 volt. And if we use 20 ohm resistor, which is recommended here in the test, at that time it will switch until 5 volt to 30 volt. That is breakover voltage. At breakover current and breakover voltage, these are the symmetry voltage, forward current in both directions, forward current and reverse forward current. And this is its rise time calculation. I hope so this video is informative. If it is informative, please like this video and share with your friends. Might be it will helpful for someone. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.